Hello, my name is Steve Larson. I'm an engineer at Cat Pumps, and today we're going to talk about cavitation. We're actually going to do it in a two-part discussion. In the first part, we're going to talk about what is cavitation and what does it do to your pump. And in the second part, we're going to talk about designing a system to prevent cavitation. Well, to begin with, what is cavitation? Cavitation is working with a pump. There is a chamber inside the pump called the pumping chamber that has to fill with liquid each time you draw the plunger back and empty with liquid each time you push the plunger forward. To demonstrate this, I think it's a good time to hit the whiteboard, and I'm going to draw a pump manifold with a plunger going into it, and also I'm going to put a inlet check valve, a discharge check valve, and to show the direction of water flow this way through the pump. When a plunger is retracted, it's in this position, and then in the forward stroke, it's got to move forward a distance equal to the pump stroke. Now this chamber that I've outlined with a dotted line represents the volume of the pumping chamber or the displacement of the pump with one cylinder. So each time the plunger comes back, it retracts and liquid is drawn up through the inlet valve into the pumping chamber. Then when the plunger goes back forward, it pushes the liquid out the discharge valve. And this volume of liquid then is called the displacement of the pump. Some pumps are larger, some pumps are smaller. But for this example, we're going to talk about a 40 cubic centimeter displacement. That's the volume of that pumping chamber. To operate the pump properly, every time the plunger draws back, it needs to draw in 40 cc's of liquid, and then it'll push out 40 cc's of liquid. If there's something in the nature of the system or the water or the speed or whatever it be, so that when I draw the plunger back, I only get in 38 cc's of water, I have now created a condition called cavitation. And what happens is I only get 38 cc's of water in there, but what happens to the other 2 cc's of volume that the plunger has moved? Well, what happens is you get a low pressure regime right in some part in this pumping chamber, and it will change a few drops of the water from liquid phase to a gas phase. So it's changing the state of the fluid. What that does is you're taking it from liquid to a gas on the retraction, and then on the forward stroke, you're pushing it back from gas to liquid, which you're changing the phase. And those are a violent reaction that occurs, and it's called actually cavitation, or there's an implosion that is going on in there. And the reason only it takes a few molecules of water to fill that void is if we think of when we're boiling water. If we take a gallon of water and we would boil it all into steam, we would have approximately 1,600 gallons of steam. So just by changing water from a liquid to a gas, its volume changes by 1,600 times. So it only takes a few drops or molecules of water to expand into a vapor and fill the remaining part of the chamber. And so that's what cavitation is not filling the chamber completely and getting some of the water turning from liquid to vapor. Now, why is this bad? Because what it does is those implosions are very violent in there, and they will attack the surfaces of the valves, attack the surfaces of the valve seats, attack the surface of the plunger, even the manifold surfaces you can find it in sometimes. But most of the time you see it in the valves and valve seats where these transitions are, where the transition of the water is going from starting and stopping as the valves are moving. That's where you see them mostly, and sometimes you see them as pits in the ceramic surface of the plunger, and then those surfaces will ride across the seals and then tear up the seals. So letting your pump run in a cavitation state is very bad for it. It will reduce the life of the pump, the seals, the valves, and you'll be able to see it by evidence of the pitting in those surfaces on the parts. So that's what cavitation is, and that's what it does to your pump.